Hello everyone. I made this project a while ago, but I got busy and haven't touched it in a couple of months, so I figured I'd put together a demo and share it with the world a little bit. If you know anything about me, for whatever reason, you may know I own this little website called gizmodic.software, and I am a freedom fighter for gizmodic software everywhere. This led me down the path of wondering, what would a fully gizmodic system built from the ground up look like? Originally I made a Linux distro where the init and package management were fully Lua, but since then the init system has been dropped and my package management work has been absorbed into another distro's development, which I can't really talk about at the moment. Then I tried making a kernel module that would add a Lua interface similar to the one in the NetBSD kernel to the Linux kernel, but that was a bit of a lost cause for a few architectural reasons, which I may put on screen here if I feel like it, and if I do, you better pause because I probably put a lot of work into writing it and you should feel bad. Which eventually led me to start working on my own kernel, which I called Syzygy, which has since been renamed to doohickey. Unfortunately for me, I do not have a schizophrenia diagnosis, so I'm not the greatest OS dev, and I don't have much to show, but here we go. This is Gizmos, a doohickey distribution. Or well, this is actually just GNU Grub, but I'm gonna boot into Gizmos now. This system behaves like a normal operating system in a lot of ways. It has a boot process, it initializes hardware, and it can run code. So I'm not going to spend 10 minutes showing you things that every operating system does. Instead, I want to focus on the places where the philosophy behind Gizmos actually shows through. For example, the file system. I can create a directory like this. And then I can create a file inside of it like this. And then I can read back from that file like this. This looks like a hierarchy of Lua objects because, well, that's essentially what the file system is designed to be from Lua's perspective. Directories can be accessed like objects, files can be assigned to, and normal Lua operations like pairs can be used to iterate through a directory. So I can do something like this. And that gets the contents of the directory back. The file system itself is very tiny. There are just 256 nodes, and each node stores a name, a type, a parent index, and, if it's a file, a pointer to its contents. Directories don't actually store a list of children. Instead, to enumerate a directory, the file system scans a node table for every entry whose parent points back to it. There aren't any paths stored internally either. A path like home demo message is simply a sequence of lookups, starting at the root and following one name at a time until the destination is reached. Each file system node is represented by a Lua user data whose meta methods translate ordinary Lua operations into file system operations. Accessing drive.home.demo performs a lookup, assigning a string creates a file, assigning a table creates a directory, and assigning nil removes it. The same philosophy shows up in the multi-core design as well. Most kernels have multiple threads sharing the same address space and runtime. doohickey doesn't. Instead, every CPU gets its own Lua state, each processor has its own globals, its own stack, and its own garbage collector. The bootstrap processor runs the REPL, while the other processors wait for work. So, for example, I can submit a task to another CPU like this. That code isn't running on the same interpreter as the REPL. The scheduler places the source code onto a queue, and the target processor executes it in its own Lua state. That means CPUs can't accidentally reach into each other's globals or corrupt each other's interpreter state. If they want to communicate, they have to do it explicitly. For that, Gizmos has named IPC channels. Underneath, those channels are just fixed-size ring buffers protected by spin locks, but from Lua they're just another object you can pass messages through. It's a very simple model. The kernel does actually support networking. Networking is kind of inherently boring though, at least from a design perspective. Once you've implemented Ethernet, ARP, IPv4, TCP, UDP, DHCP, and DNS, you've implemented Ethernet, ARP, IPv4, TCP, UDP, DHCP, and DNS. There's not a whole lot of room to be clever without making things worse. Rather than using interrupts, the entire system is polling based. The network card is periodically checked for incoming packets, the keyboard is polled, the mouse is polled, and disk operations are synchronous. That obviously isn't the most efficient design in the world, but it keeps the control flow incredibly straightforward. Nothing suddenly interrupts the CPU halfway through some unrelated piece of code, so I don't have to make every subsystem resilient to arbitrary asynchronous execution. For a general purpose operating system, that would probably be a terrible trade-off. But for a hobby operating system where the main workload is just me typing into a REPL, I think it's a pretty reasonable one for now. There is a high-level HTTP library in Gizmos built on top of the lower-level networking libraries provided by the kernel. For example, I can make an HTTP request like this. The networking is a little bit slow, so give it a second. or download something directly into the file system. Underneath though, that request all goes through the entire networking stack, of course. Right now, the only network card supported is the Intel E1000 because that was the easiest to write a driver for. The driver is written in C, like all the other drivers, but one day it would be nice to be able to write these drivers in Lua as well. But that wraps up this demo for now. I'll talk more about it after this segment. So, that was Gizmos. There are obviously a lot of things I didn't cover. I could spend an hour talking about the scheduler, the boot process, the network stack, or all the little implementation details that make this thing work. But after showing this project to people, I've noticed they tend to ask the same handful of questions. So rather than pretending this video is comprehensive, I figured I'd answer some of those now. Why Lua? Honestly, because I like Lua. It's small, embeddable, and has a really nice C API, and it's flexible enough that I can make things like file system nodes feel like native Lua objects without inventing an entirely new language. And of course, I wanted to build a computer where basically everything is Lua, so I did. Is this viable on real hardware? Yes and no. It runs on real x86 hardware, although the hardware support is basically non-existent. It's not going to boot on every random PC, but that's not really the goal right now. Why not just use Linux? Because that would kind of defeat the point. I wasn't trying to build a better Linux. Linux is already very good at being Linux. The whole idea behind this project was to see what happens if you start from a completely different set of priorities and build an operating system around those instead. What inspired this project? There are a few answers. Serenity OS was probably my biggest inspiration. It showed me that operating system development is something you can do to just pass the time. Temple OS as well. It's one of the strongest examples of someone committing completely to a single vision for an operating system. And then there's also Java OS. I don't think many people remember it, but the idea of building an operating system around a runtime instead of just treating that runtime as another application definitely influenced this project. Will it have a GUI? Maybe. The closest I've gotten to this is a mouse driver. I'd like to do it eventually, but I'm not a graphics programmer, and graphics programming is hard, so for now, no graphics. Will you improve the file system? I hope so. The current file system is intentionally very simple, and I think there's plenty of room to make it more capable without losing what makes it interesting. That said, file system development does things to a person. There are file system developers who start out perfectly normal, and then one day their hands riser. Why isn't the source code or a distribution available? Because I'm not ready to release it yet. There are still parts of the codebase I'm not happy with, and I'd rather wait until I can release something I'm actually proud of than rush it out because people are curious. There's also a more personal reason. I spent a lot of time building this thing, and it honestly feels a little bit like my child. Not because I think people shouldn't criticize it, they absolutely should, but because I'd like to be emotionally prepared before I watch it get brutalized and violated publicly. Will this ever actually be usable? Not in its current form. A lot of the design decisions that make Doohickey fun to build also make it a pretty questionable choice for a general-purpose operating system. Will this ever have any practical applications? Probably not, but I do think it has value as an experiment. Maybe it would be useful for education, embedded systems, or experimentation. Maybe it wouldn't. Why are so many parts of the system so simple? Because I'm one person and I would quite like to finish it, and I also don't necessarily want to collaborate on it with anyone. What's your favorite part? Probably the file system. It's one of the most unique things about this system. What was the hardest part? Getting everything to fit together. Writing individual subsystems isn't that bad. The difficult part is making them all cooperate without creating a giant mess. What spent the most time broken? Networking. When you're writing networking code, nothing breaks in a predictable way. I spent 2 weeks in Wireshark full-time analyzing the virtual machine. Can it run normal programs? No, that's a very anti-gizmodic thing to ask. It isn't trying to be POSIX compatible. The whole operating system is built around Lua, so if you want to run code on it, you write Lua. Is it secure? Probably not. Not a single soul is writing malware for it though, and as we all know, security through obscurity always works. I'm sure there are also a bunch of questions I haven't thought of, so you can leave a comment if you want Google to have another piece of your personal data to do whatever Google does with it, or you can email me or reach out to me over XMPP.